Welcome to the pollinator meadow. Out here, as hummingbirds and butterflies forage for nectar, the number of blossoms and the drops of nectar collected always scale together. Visualize this relationship on a double number line. As flower blossoms grow, the total drops of nectar increase, stretching outward together. Trace that back to a single blossom to find the unit rate, the exact nectar amount corresponding to the number 1. Finding that specific per 1 value is your crucial first step. Once you know the unit rate, you have the baseline for proportional reasoning. A recipe uses 3 cups of nuts for 5 cups of fruit. To find the nuts needed for 1 cup of fruit, divide both quantities by 5. 3 divided by 5 is 0.6. The unit rate is 0.6 cups of nuts per cup of fruit. This mechanical division step works consistently because a unit rate does one specific job. It names the exact proportional amount of one quantity needed for exact 1 unit of the other. Pricing requires this exact same logic. Let's say a bundle of 4 field notebooks costs $6. We need the price for a single notebook. To get that rate, we take the total cost and prepare to divide it by the total items. Take a moment to calculate this step yourself. What is 6 divided by 4? 6 divided by 4 equals 1.5. Translated back into currency, 1 notebook costs exactly $1.50. When you handle pricing, the item you want exactly 1 of tells you what to divide by. If you want the price for 1 notebook, divide by the total notebooks. This visual trail map applies the unit rate rule to speed. Imagine a fox traveling 12 miles along this path over a period of 3 hours. Notice how the total distance and the total time advance in tandem. To find the speed in miles per hour, we divide the 12 miles by the 3 hours to isolate the distance covered in just a single hour. 12 divided by 3 is 4. The unit rate here is 4 miles per hour. Speed rates connect 2 completely different units of measurement. They show exactly how many miles pair up with a single hour of time. The framework remains identical whether you are measuring trail mix, notebook prices, or a hiker's speed. You are always answering the prompt, for 1 blank, there are blank. To find that missing number, you always scale both quantities together. Once you know how to reliably translate a ratio into its per 1 value, you are equipped to handle complex rate problems, proportional relationships, and eventually the mathematics of slope.